Hi and welcome to a Kirby Maths video about using bounds in calculations. So we have a problem here where we are given some information about a car journey, and the distance travelled was 80.3 miles, and that was to one decimal place, and the time that it took to do that was 1.7 hours, and that was given to two decimal places. We're asked to do three things. First thing we're asked to do is work out the upper bound of the speed. The second thing is the lower bound of the speed, so the minimum speed, and then finally the average speed to a suitable degree of accuracy. Now, the phrasing suitable degree of accuracy often occurs in bounds calculations, and when we get to part C, I will show you exactly what that means. First of all, then, let's do the upper bound of the speed. So we need to use our speed distance triangle. So speed is equal to distance over time. Put it in our triangle. We're trying to work out the speed, so we cover that up. So the speed is equal to the distance divided by the time. Now we need to use bounds for this, and we're going to start off with our distance. So we have 80.3. Remember, we're going up half a unit and down half a unit, and we're to one decimal place. So our upper bound for our distance is going to be 80.35. That's up half a unit. Our lower bound for speed is going to be 80.25, because 80.3 lies right in the middle of those two numbers. That is our distance. For our time, we've got 1.87 hours, and that is to two decimal places. So our upper bound for this, going to go to that third decimal place, will be 1.875, and the lower bound for the time would be 1.865, and again you can see 1.87 lies exactly in between those two. Do not worry if you're given the time like this, we don't need to convert it into minutes or anything like that. We're just going to do speed equals distance divided by time. So the maximum speed, the upper bound of the speed, we're trying to work out the biggest value the speed could be. We are going to take the maximum value of the distance and divide it by the smallest amount of time. So we're going to use the distance upper bound, and we're going to divide it by the time lower bound. That would be 80.35, our biggest number for the distance, divided by our smallest number for the time, which is 1.865, and that gives us a value of 43.08310992. I've written down everything on my calculator display. In the question you probably have to round it to one or two decimal places, and you'd be asked for that, but I'm just going to leave it like that for the minute because we need that value when we're working out part C. So that was part A. That would be the maximum speed. If we're working out the lowest value of the speed, so the lower bound of the speed, that would be when we had the smallest distance taking the largest amount of time. So it would be the lower bound of the distance divided by the upper bound of the time. So the smallest distance divided by the largest time would give us the smallest speed. So that would be 80.25 divided by 1.875, and on your calculator that comes out to be 42.8. Okay, so that's part A and part B. Now, when we go to part C, I'm going to go down here. When it says a suitable degree of accuracy, that means as far as possible, so as accurate as you can be with those two numbers agreeing. Okay, so I'm going to start off by writing them to one significant figure. Okay, so one sig fig for both those speeds, the max and the minimum. This number to one significant figure is 40. So the speed upper bound is 40, and the speed lower bound to one significant figure, this is also 40. So they agree to one significant figure, but I'm going to try and see if I can get it more accurate than that. So now I'm going to two significant figures. This number to two significant figures is 43. So the speed upper bound is 43, and the speed lower bound to two significant figures, 42.8, becomes 43. So they agree to two significant figures. If I try and be more accurate than that, three significant figures, this number, the speed upper bound to three significant figures is 43.1, and the speed lower bound to three significant figures is 42.8. So they do not agree if I round them to three significant figures. The most accurate I can get is two significant figures. So C, they both agree to 43, what's this going to be, miles per hour, and that is to two significant figures. And that is my suitable degree of accuracy. Thanks for watching.